Good afternoon, folks.
Good afternoon.
Welcome to the session of Falcon Flight. I hope you guys are as excited as I am because we are having only 25 minutes together. And we are going to make every second of it counts. Okay, so let's get started. I am Sanchit alongside Arpan. We both work at NPCI as Senior Associate Blockchain Developer. Without any further delay, let's move to the agenda. So firstly, we'll briefly touch upon the concepts of EAD and blockchain. Then we'll get to know what's the first about Hyperledger Fabric. Then we'll delve into what is Falcon, what and why of it, why it is there. Then you all will be witnessing Falcon in action. And last but not the least, we'll be open for any questions. Right? Cool. So what is EAD? So, what is ELD? You might have heard of this term, ELD, and if so, then you also are aware about blockchain as well. ELD is distributed ledger technology, which enables data sharing across a network of nodes. Right? It can be stored in any form of data structures. It can be limited. And about blockchain is a type of ELD. Distributed ledger technology, which stores data in form of cryptographically linked blocks, which forms a chronological chain. Blockchain is immutable, it is decentralized, distributed, it is secure, it follows consensus algorithm to run the transactions, to commit the transactions. And the blockchain is broadly divided into two types, public one and permission private one. Right? So coming to public blockchain, examples are pretty much common, Bitcoin Ethereum, but it serves to crypto-related use cases and more or less B2C use cases, business to customer use cases. On the other hand, when it comes to permission blockchain, it is widely adopted in B2B use cases, right? B2B and the leading permission blockchain is Hyperledger Fabric in this game. So, what is blockchain? You know it right now. Then, what is Hyperledger Fabric? Hyperledger Fabric is an open source project hosted by Linux Foundation. So, it is designed and developed to provide blockchain solutions with a modular architecture. The key components of Hyperledger Fabric are peers, orders, channels, membership service provider. And all of these components are modular that you can just do plug and play with them. Anything you want to design and develop, you can just plug it and do it on your own. Right? So, what use cases Hyperledger Fabric is serving to? It has a very broad array, starting from supply chain management. It also caters to identity management. Then finance sector is very huge, which Hyperledger Fabric is broadly adopted. And not the least, healthcare sector as well. There is a challenge of maintaining and deploying production grade fabric network, which is very complex to deal with. Complex to deal with in terms of when you are going to host like 500 nodes across region, across continents, then how are you going to manage it? Then comes into the picture of Falcon. Now I'll hand it over to Arpan. He'll take it forward from here.
Hi folks. So without any delay, let's introduce Falcon. So what's Falcon? If I want to summarize Falcon in just one line, it is a journey from cumbersome and time-consuming deployment to a streamlined and production-grade templatized deployment. Falcon is an open-source project hosted by NPCI. It aims to simplify the deployment and maintenance of a Hyperledger Fabric production-grade network on Kubernetes clusters. Hyperledger Fabric streamlines the process of configuring, maintaining fabric nodes, peers, orders, and other components in the fabric network on a Kubernetes environment. Falcon gives us templatized Helm charts, which makes configuration easy, and developers or administrators can spend much more time in implementing the business logic rather than spending much time debugging the deployment. Falcon also provides lifecycle support for all the major fabric components such as CA, the certificate authorities, and MSPs, chain code, and channels. So let's move on. So now we know about Falcon, but why do we need it? What are the advantages? So in traditional deployment, as I said, manual configuration of all the components are required. There are a lot of manual steps which are involved, which are automated and streamlined by Falcon with the help of templatized Helm charts. Apart from that, a major pain is deploying and managing the certificate authorities, where administrators quite struggle a lot. But Fabric automates the management of certificate authorities and it handles the CA lifecycle automatically, including issuance of certificates and renewal of certificates during the time of expiry. Deployment of peers and orders, which are also a core component of Fabric network, is also quite error-prone because it requires a complex amount of configuration, which is also streamlined by Falcon. Apart from that, there is automated lifecycle management for channels and chain code, which facilitates automatic management of the chain code lifecycle, installing, approving, committing new chain code, which pushes business logic to all the organizations, which is automated, which is something which is also cumbersome in the existing traditional deployment. One of the major USPs of Falcon is multi-DC support and private network support. Falcon supports multi-zone, multi-DC deployments. It seamlessly deploys in private cloud, public cloud, and air-gapped environments. Apart from that, Falcon provides production-ready deployment, which is seamlessly ready to integrate with prominent monitoring tools like Prometheus and Arpan. So before we jump to witness Falcon in action, let's look at some of the prerequisites that we need to configure. So before we deploy Falcon, we need to have an Nginx ingress or a load balancer which supports SNI-based routing. Apart from that, we need to configure SSL pass-through to allow SSL connections. Then we need to configure DNS records to support domain name routing, which is again not supported in the traditional deployment. We have to do manual extra steps in order to support domain name routing. And last but not the least, Falcon provides you a deployment which is independent of storage class. So there might be a requirement on many environments, especially air-gapped environments, which supports only particular storage classes. Falcon is independent of that. You can configure any storage class to work with the deployment of Falcon. Now let's witness Falcon in action. I'll hand it over to Sanchit.
Another deployment, Hyperledger Fabric deployment with Falcon. So firstly, we would be needing a centralized repository. For that, we'll be deploying file store, which is nothing but Nginx server, which can serve as a central repository. This can hold any common files that is required for the network. So we'll be using Helm charts to deploy most of our components, and this command basically is going to deploy a file store. In the other stream, we'll be seeing that whatever is deployed will be visible here. Okay.
So in Hyperledger Fabric deployment, there are a lot of configuration files that needs to be shared with the organizations which are part of the network. So in the traditional deployments, we need to share those manifests manually with other organizations when they are deployed on other nodes. And using file store by Falcon, it acts as a central server to which all the nodes or organizations can connect, and they can fetch all the configuration files that are needed.
Okay, so it is deployed. To verify whether it is working or not, we will be using simple curl command to hit it. and it is giving us the response, success response. Now, first component, the root CA, root certificate authority. We are going to deploy this certificate authority now. In order to do this, we have to create a namespace and then create some secrets that will be required as a admin credentials.
So root CA is one of the certificate authorities that I mentioned that Falcon automates. So the simple command that sets up root CA is much more complicated when you go with the traditional deployment because it requires a lot of configuration, a lot of prerequisites that you need to set. You need to configure all the certificates manually. But here you will see it is all automated and it is simplified.
So here on this second terminal, you are seeing the result of whatever I'm running in a command. As part of your knowledge, this is a Kubernetes cluster that we are running in our local system with kind. So it is up and running. Let's test this, whether the root CA is up or not. This command should give us the root CA certificate. And here it is. It returned successfully the CA. Now comes TLSCA. This TLSCA will serve to the certificates that are going to be used in terms of communication between the network, between all the other components.
SSL pass-through enables this communication from all the other components on the network with TLSCA.
It is up and running now.
So once the root CA and TLSCA is up and running, we need to register the identities of the next upcoming components with the CA authorities, which will be the IC component or the intermediate CA components with the root and TLSCA. So you can see there are two ops running, which is one is of order, which is one of the major components, and will be enrolling or onboarding one organization named as Arpan to our network. So we are both registering the identities of the intermediate CAs of order and Arpan with root CA. Next, we are registering the identities of order components with the TLSCA along with the peer components of Falcon with the TLSCA.
So, as TLSCA and root CA is already deployed, now we'll move to deploy the ICA, which is intermediate certificate authority. For that also we have to create some secrets that will be consumed by our Helm charts. This will install ICA for order, as you can see in the slide as well. This one.
And since the identities of
Yep, it is up and running now. As part of demo, we'll be showing you how to add organization as well. So Arpan is the name of the new organization that we are going to have in the network. Secret is created. Set to deploy ICA for org manager. You can see it here.
So there is an init container which runs in all the components such as ICAs, which will fetch the certificate by enrolling itself with the use case. So now that the ICA order and the ICA of org1 is in place, we can go ahead by registering the identities of the components of order with its own ICA and the other components of org1 with its own org1 ICA.
So all these ops of registering, enrolling, and whatever it is, so it is a part of job, Kubernetes job. And it runs, it completes, and it vanishes.
We have registered order with its own ICA. Now we are registering peer 0 of org1, peers of the org1 with its own ICA.
Yeah, complete. So deploying ICA and registering the identities are done. Let's move on to deploy the orders now. Before deploying the orders, we have to create a Genesis block and the channel transaction file.
So for your information, Genesis block is basically the first building block of the blockchain that will be running. And the channel file is basically utilized to create a channel for communication between different organizations on the network. Channels, you can think of it like a private subnet for a list of organizations. They can communicate on that channel and the data of those organizations are isolated within that channel. So that's how private data is supported in this Fabric network. Maybe you can show this.
So the Genesis block and the channel transaction file is created and is being pushed to the file store that we have created at the beginning. So from the file store, this Genesis block and channel transaction file can be shared across the network with any organization which is going to be onboarded in future. You can see this job is completed. It is not less completed. Now we are going to deploy the order. This order will fetch the Genesis block and then install it.
So in order, while coming up, there will be an init container which will run on each of the orders, which will enroll itself with the IC of order and fetch its own certificate to identify with the network. So a lot of things that are being done internally are, I would say, cumbersome steps which are a bit complex and takes a lot of time in the traditional deployment if you are going by the Hyperledger Fabric traditional deployment. But with Falcon, a lot of things are abstracted and automated.
Waiting for orders to come up. Now order is being deployed now. Let's move to deploying peer of organization 1. So as you can see, peer 1, 3 peer of organization 1 is spinning up. There are 3 containers inside this peer, which is Cows TV, it is one is Dindy, another one is peer binary.
So in the traditional deployment, when the orders come up, they need to connect with each other in order to elect a leader. Who will be the leader for ordinary transactions, which is often based on IP, which if the traditional deployment mostly deploys the Dockerized network, so it is based on the IP of the Docker containers. Here it is completely domain based. We have ingress and we have set up the DNS, so it will connect to each other with its own domain and independently. So once the peers are running, they will connect with the order to fetch the current blocks that have been committed to the chain code.
So peers of organization 1 are up and running now. Let's move to the next component of it, the main thing, channel. We create the channel and orders and org1 will join the channel.
So previously with the Genesis block, we created a channel transaction file. We will be utilizing this file here while creating the channel, which will be dynamically fetching from the file store. So in the traditional deployment, a lot of these files configurations are required to be shared manually. They might get corrupted while sharing, they might get missed while sharing. So the deployment can fail. But Falcon ensures that with the streamline, it is abstracted away, so you don't have to worry about it.
As channel is created, we are going to update the anchor pair for organization 1. It is done.
We are done with the presentations and we are happy to answer your questions.
So you can see, just a second, you can see the network, HLF network get deployed in approximately 10 minutes within a talk. And this was not possible before. And this is, believe me, this is a production grade network which is deployed here. So any questions we are open to answer, we'll be more than happy to answer.
Can you please give a real use case of this procedure? I am unable to correlate.
A real use case for this procedure.
So, Hyperledger Fabric is a very popular blockchain network which is being adopted widely in private permission or B2B use cases. So, a lot of companies who are trying to migrate their networks, like their supply chain or any financial system or any healthcare system to a blockchain network which is private to their organization. So they will look at Hyperledger Fabric, which is one of the major containers in the private permission blockchain space. So there, when if suppose they are trying to onboard their network, their organization to the Fabric network, there we face a lot of challenges with the traditional deployment that Hyperledger Fabric has currently, which is built in. They deploy a Dockerized environment, and they do not support Helm Kubernetes deployments natively. So Falcon basically builds upon that. Falcon abstracts away the nitty-gritty details of that and gives you templatized deployment which can configure to your own needs and you can deploy within minutes and maintain it seamlessly. So,
Thank you.
Hi, my name is Sudhir. My question is Falcon a CNCF project? And if not Falcon, what are the alternatives for deploying Hyperledger?
Can you repeat the question, the first part of it?
Falcon, is it a CNCF project?
No, it is not a CNCF project. It is a open source project, and it is developed by NPCI, and then later it was turned to open source under GNGPL 3.2 license. And about what are the alternatives? So, firstly, native approach, you can do it. Secondly, there is one more project, which is Bevel. Hyperledger Fabric. It also provides this deployment strategies for the production grade network. But if you want to understand the challenges what Bevel is also having, then I'll say you cannot maintain the versions of what you are deploying in your network. And maintainability is much more easier in Falcon rather than Bevel.
So we have seen like lifecycle management is quite a challenging level. So what we have overcome in Falcon. Apart from that, configurability also when we rigorously perform the developments of Falcon and rigorously mandatory code. So Bevel is a bit limited on the options that it gives for configuring or so Falcon SLT it seamlessly deploys on private public air-gapped environments. So that is something that Falcon does better than Bevel. But there are other challenges as well.
One more point adding to Arpan. So Falcon natively supports the multi-DC deployment. You can deploy one organization in one DC, you can deploy a second organization in another DC. They can communicate over it. So Falcons give this as a base feature where Bevel lacks it.
Rest of time, let's wrap it up and you can connect with them offline if you have any further questions.
Before we close, I would just like to pitch what's next for Falcon is you can expect multi-channel support. You can expect a complete observability stack, which is currently in progress that we are doing. You can see that GUI-based deployment which will be coming to Falcon, so you'll be able to deploy one click a complete network
From UI.
And then there will be some more Fabric Explorer and Fabric tools which are maintained by this Fabric. That is the foundation that will be involved. So this is what is upcoming. It is an open source project. We are open for contributions and your collaboration as well. Thank you. Thank you to us and Sanchit.
Thanks so much, Arpan and Sanchit. I think we will give away that token of appreciation.